was a great talk. I mean, I've said it. I said it multiple times that I'd love to. Oh my God! Oh dear.
So our next speaker is Louis. I don't think Louis needs an introduction, but his bio is so short for this anyway. He's a security engineer based in Melbourne, and he is the founder of Pentester Labs, a learning platform for web penetration testing. I think a lot of people know about Pentester Labs. He's also the creator of the Silvio stickers, and even worse, a couple of weeks ago, he decided to make Silvio a lord.
I do have the certificate. I'm very proud of it. I posted it everywhere.
As if it wasn't hard enough in my house already. Thank you, Louis.
My lord.
Yeah.
Oh, can you hear me okay?
Perfect.
Okay, perfect. So let's get started. So today I'm going to talk about Entomology 101. So basically an introduction to studying, collecting, and finding bugs. Let me get to the right window. So basically my job, Pentester Lab, is to find, collect, and study bugs to help people learn what is important when you're testing web application and how you can find, fix, and exploit these bugs. And this talk is about how I do that. So first, if you're like me, so basically if you're not Silvio, you're unlikely to find like new vulnerability classes. You're most likely going to find like a bug class that someone already found and in a new project, or found a little derivation from an existing bugs or an existing bug class. And that's why it's so important to learn existing patterns to be able to know like, okay, I got these patterns, that looks like something that is a vulnerability. And that's going to allow you to find a lot of bugs. So first, to do this entomology, what you need is to start collecting bugs. So a good way to collecting bugs is look at what people are doing. So first you can look at, for example, mailing list security. People are still using emails. Two that I really like is Apache, announced at apache.org, because it's going to give you like all the new versions of Apache projects. And with new version, you got vulnerabilities fixed. And so you can dive deeper to see like, okay, what was the bug, what happened? Ruby on Rails as well. I'm a big Ruby guy. So, and it's a project that is mature enough. So when there are new bugs in Rails, you can be sure that they're not trivial. They're not something very simple. So it's interesting to look there. You don't want to follow or look at projects that are really immature, because otherwise there's going to be like hundreds of silly bugs, and that's not where you're going to be learning. Another way to find new bugs or new patterns you don't know about is to look at bug bounty disclosure, either by following Twitter or like disclosed H1, Bugcrowd as well as a disclosure, same for HackerOne with activity, and a lot of bug bounty write-ups from bug bounty hunters. So again, that's going to give you a lot of details. The problem you're going to have with that is that you have two things. You only have the information from the researcher who is doing like closed box testing. So it's very limited. And you only have the information in the way the researcher presented it. So sometimes you are missing a lot of information through that. But it's always good to look at, because some researchers do write-ups that are freaking amazing. Then, like if you look at collecting bugs, you can find like, you can get in your mailbox things like that. So that was an email from Apache mailing list saying like, okay, there is this bug in Kylin, and then it's an SQL injection. So you get that and you say like, okay, let's dig deeper if you got time. And another way to collecting bugs is to look at Twitter. A lot of people to follow that are publishing bugs every day. I don't want to list people and forget someone. Try to find people who share information on bugs, Like people are going to be like, okay, oh, I find this bug and no information shared, so that doesn't have a real value. People like Silvio, for example, are extraordinary at sharing information about the bugs they found, so you can learn from them. If you just have like, oh, I get 20,000 by finding these bugs and you don't know anything about it, there is nothing to learn about it. So try to find people with like a high signal versus noise ratio. Someone who talks about bugs, who talks well about bugs, explain them well, and don't spend their time on Twitter talking about other stuff you don't care about. Other obvious sources, the Project Zero trackers, conference and local meetups. You often have people like talking about things they found. So that's really interesting. Blog, RSS, RIP, Google Reader, I guess. And Reddit, NetSec is pretty good, or CTF as well is a good way to learn about new things, because people writing CTF challenges are not here to keep other people busy. They're here because they want to share their knowledge, and they want to share information about something tricky, a weird behavior, or something interesting for other people. So CTFs are a really good way to learn about new bug classes or bugs you may not have heard about. So check them out and play. Once you got all this collecting, you need to start studying bugs. So a good way to do that is to check the source code. So you find the vulnerable version and the fixed version, and you do a diff. On Twitter, it's literally like a few clicks. On the GitHub, sorry, it's literally like a few clicks. So really easy to see what was the change. And from that, just by doing these few clicks, like barely nothing, right? You got from that there is a version that is vulnerable, that version that is not vulnerable. So 3 clicks. What you're going to learn a lot, you know what the vulnerable code looks like. You know what the bug precisely is. Like, okay, they talked about SQL injection, but what kind of SQL injection? What is really happening? You have an idea of the exploitability of the issue, because there are really hard to exploit bugs and really easy to exploit bugs. So by doing a simple diff, when you have access to the source code, you get this information as well. And you know how to fix that bug as well. Hopefully it's done properly. So that's give you, like, when you're doing, for example, a report as a pen tester, you're going to say like, okay, this is the same bugs as these bugs I already looked at, because I'm doing all this entomology. And so I know exactly what recommendation people should apply, and hopefully they fixed it well. And as well, it's a good way to get an introduction to a code base. By looking at security issues in that code base, you're going to know, like, okay, this is a function that is important when we're dealing with SQL data. This is a function that matters when we're doing cross-site scripting escaping. So you're going to learn the code base without having to spend too much time on it. And you're going to be able to see a lot of different code bases. So for example, for the bugs I was talking about in the mail from Apache, you can see that, okay, this really looks like a trivial SQL injection. And we can see by that to fix it, they're just going to use prepared statement. So very simple change, like few lines to read, and you got like a lot of information of how SQL injection works, what happened with when it's wrong, what is the right way to do it. So you're learning a lot by just reading like 10 lines of code. So a good way to learn. Once you learn a bit more about this bug, what is interesting is to build a test environment, because it allows you first to learn how to deploy software. It's not always easy to deploy software, even if it's a lot easier now with Docker. Sometimes it's just one command thanks to Docker. Like a lot of open source projects now have Docker files, so you can just like run Docker build and Docker run. It's going to help you study someone else's exploit if you can't write your own exploit yet. Then once you study someone else, you can build your own, or you can just build your own and not look at what other people are doing. You can exploit the issue. And then once you got this test environment up and ready, why not keep testing, right? So that's a good way to keep testing. You say like, okay, they had this bug. Maybe there is something similar that the person finding the initial bug didn't look at. So it's really good to have that ready to fuzz and look at. Then once you start studying a bug, what is interesting is to extrapolate. are there any other identical pattern in the same project? Because often developers will fix one instance of the bug and forget other instances. And can you find the same pattern in other projects? Like really, really easy thing. So like, okay, this is like a string concatenation in a SQL query. Can we find that in another project? For SQL injection, it's probably a bit easy because everyone knows about it. But when you think about header injection in the host header to like on a password reset, maybe not as many people have looked at it. And try to see what these patterns translates in other languages and framework. Like, okay, this is an SQL injection in Java. What does it look like in Golang? What does it look like in Ruby? What does it look like in PHP? Like, it's a really good way to find new bugs because people don't necessarily do that work of like looking in other languages or framework. Then once you're done with the studying, you probably want to document your findings. Keep notes on the bug and the source code and the fix, keep the exploit and the tools to run it, and maybe share this in a blog spot or do a write-up, blog spot, do a talk at work, your school, your local meetup, tweet about something people may not know about that bug. Like often you can see like a lot of people tweeting or retweeting about one bug, but no one is adding information to Twitter. People are just like repeating the same thing again and again or adding a joke to it. If you can add value to say like, oh, actually this is only exploitable because of that, or actually you can exploit it in a better way using that, it's gonna give you like, if you're looking for a job, that's a good way to like get people interested in your profile. Then hunting for bugs. So once you got your nice collection of bugs ready, you learn about all these things and you know all these new bugs, what you can do is start hunting. So first you can do like bug bounty programs. The problem is that you're gonna have limited access to source code. So it's not always ideal if you want to do that at scale. If you want looking for targets, GitHub trending is pretty good. I like DigitalOcean Marketplace. I like AwesomeX, like Awesome Go, Awesome Ruby on GitHub. People put together like a list of really cool projects in their preferred language. I use that a lot to like find bugs. Hacker News as well. Someone is going to put like, oh, this is my new open source project. That's a good target to look at. And to get started, like, so you just build your test environment with enhanced debugging if possible. You can get familiar with the source code if available. Doesn't take long to like just grab for things that are interesting and say like, okay, where is the password reset function? Where is the login function? How are password hashed? What happens? Pick a few of the weird patterns for the language framework used based on what you learn from collecting bugs. Let's say, for example, you know that in Ruby on Rails, in Ruby, you have in regular expression, end of string and end of lines are different. That's a good pattern to look in every single Ruby project you find. Then you spend hours in front of a computer, probably not the funniest thing, but make sure you like finding bugs. You don't like the idea of finding bugs. Those things are really different. You need to really enjoy like looking for bugs to get good at it, I guess. And yeah, learn about actually searching for bugs. Like a lot of people are like, oh, I want to get better at finding bugs. I want to get better at code review. I want to get better at hacking. Just spend the time doing it. Just don't read books, or read books, but don't only read books. Spend time doing it. And remember as well that your goal is not necessarily at the beginning when you're starting to find bugs. Try to just learn how to find bugs, learn how to read source code, learn to find weaknesses. So these weaknesses may not be exploitable, but at least you're learning new things. And if you pile up weaknesses and weaknesses and weaknesses, one day you're going to find bugs. And one of the weaknesses will turn into like a really good exploitable bugs. So yeah. One thing I find really interesting when you're talking to people and when you're looking for bugs is how this going deeper really matter. Is that, let's say you have a signature mechanism. You have few people who are just not going to say like, look for anything because there is a signature, it's signed, it's secure, right? Then they're going to look, oh, actually, no, it's, yeah. So then people who are going to say like, okay, should we look at what the data looks like? Actually, it's encrypted. It looks like a blob. Then people are going to give up there and just like say, okay, nothing to see there. Then we're going to say like, okay, you're going to keep going. You say like, oh, it's actually base64 encoded serialized data, but it is signed. And people are going to say like, oh, it's signed. I'm giving up again. Then people are looking deeper and say like, oh, the signature is using RSA. And people are just going to like either give up because RSA should be pretty okay. No, what is like not many ways to mess it up unless you're going really wrong. But people are going to keep going. Is the key strong? Oh, people are going to say like, okay, the key is strong. So I'm going to keep going. I'm going to keep going, or I'm going to just drop and say like, okay, there is no bugs. And then another person is like, oh, is the key stored in a secure place? Yes, it is. No, it's not. And people again are going to give up, where other people are going to keep going. And then someone is going to work out that the key is shared between all instances of the applications. And that happened recently. So yeah, like, and this person at the bottom, like bottom right, who spent all that time looking for bugs, that paid off for this person, where everyone gave up before that. And let's say like, hypothetically, you give like a 30% drop rate. So everyone, for every step, 30% of the people drops, which is probably really optimistic. So after the first one, 30% drop. Second one, you have 49% people left, 34, 30, 24, 16%, 11%. So that's just with 30% people dropping and not going further than anyone else before. And then if you move to 50% drop rate, which is probably still pretty low, you see that only 1.5% of people will test for the last test case because they will have given up before that. So that's why you really need to like keep going, like bang your head against the wall to just go to that, to just be in that 1.5% of people who are looking for bugs in a really deep way and find actual bugs. And yeah, because you can also, with that, learn from your bug collection. If you're reviewing this kind of code, you say like, okay, everyone got that step right, and I'm going to jump to see how the key is shared between multiple applications, because I know that the key is strong and the key is stored in a secure place. Most people got it right. So I'm not going to spend too much time on that. I'm going to jump to last step, and I'm going to be more successful finding bugs. And that has also an impact on working as a team or automation. If you can automate step 1, 2, 3, you're going to have more time to do step 4, 5, 6, right? So you're going to find more bugs. And teams as well, like when people work as a team, you can see that people keep pushing each other. Like when someone starts finding bugs, everyone wants to find bugs, and people are going deeper to find their own bugs because everyone else in the team is finding bugs. So that's why it's so important like to work as a team if you can, especially really early in your career. So yeah, just keep going to find more bugs. Don't give up. And for bugs pretty regularly, what is really good is to start to scale what you're doing. So an easy way to do it is just like go around grep in also repo, you know, but grep is pretty basic, but still worth it. And it's very simple. You can look at more complex tools like semgrep is pretty good because it's really easy to write rules for it. So you can say like, okay, I find this bug and maybe I can write a semgrep rule for it to like find this bug at scale. CodeQL is very similar, but writing rules is a bit more complex. Coccinelle, yes, Silvio, that's how you spell it because it's French for ladybird. Can be used as well for C code, and Silvio uses it a lot. And that's really important. Like if you looked at what code review tools are trying to sell you, aside from the one here, is we got this really smart software who find bugs, and you got human validating them. That's not how things should work. You should have really smart human finding bugs and then scaling their research to a lot of repository to find all these bugs. And that's why I like tools like SameGrep and CodeQL so much. But you need to be careful with unknown unknowns when you're searching at scale and when you're searching for bugs. Is that's why it's so important to not only grab for bugs or only grab for bugs you don't know. You need to read source code even if you don't think there is bugs in it, because you don't know what you don't know. And that's why you need to like keep reading software and find new bugs, because you're reading source code that no one would like looked at, because there is no like dangerous function, or there is not like a well-known function that is potentially dangerous in that part of the application. But people are still doing silly things that can create vulnerabilities. And that allow you to learn new methods, new functions, new classes that can potentially create new vulnerabilities, and vulnerabilities that no one had looked at before. I think that was Azimuth was looking to hire some intern, and they were explaining how their ways of finding bugs was more around understanding the software really well, as in better than anyone else, and then find bugs, not just like grabbing for like this dangerous function and finding bugs. So if you want to do what I guess some of the best are doing, you should probably read software, even if there is no like dangerous function there. Sorry. So what makes a bug great, in my opinion? First, you want something that is a bit weird. Like you don't want like, oh, they're not escaping value, so you have a cross-site scripting. It's like something a bit weird, something like maybe in a weird framework, weird language. Complexity of the exploitation also matters, because sometimes the bug is trivial, but exploiting it is where the fun is. And that's why you need to look at both, because you're going to learn a lot about defense in depth. Like, okay, this bug is exploitable because you got this initial entry point, but you got all these other things that are around it that could have been patched, but are not patched. And that's why you can exploit it. No one found it before. It's already a good way to tell, like, oh, it's a good bug, or at least no one disclosed it before, because when you find bugs, you never know if you're the first one. You may be the first one publishing it, but you never know if you're the first one finding it. Somehow a new pattern is interesting as well. And as well, high visibility, like when the bug impacts a lot of people, it's always fun and you get more retweet for it. And as well, I should add there, like a quality bug is a bug where the exploit fits into one tweet. Otherwise, it's just not hacking. No, I'm trolling. So what do you do with your bugs? So I'm a big believer of your bug, your role. People who complain about people disclosing bug the wrong way are often people who don't find bugs. So what you can do is responsible or coordinated, because responsible is pretty loaded as a term. Disclosure, it feels good. It can be long and tedious. It can be a good way to gain exposure when you're looking for a job. It's not always the most fun thing to do, but it's pretty good most of the time. What you can do as well is also other ways, selling it, reporting it via bug bounty programs. Like you find one bug in Ruby on Rails and you attack all the bug bounty programs using Ruby on Rails before like sending the patch to Rails. You can just send a patch to like the project you find the bug in, or you can just hold it and wait for someone else to find it. And you can even like tweet like a SHA-2 of the exploit. So like 5 years later, you can say like, I had this bug for 5 years. I tweeted about it. And yeah, you look really snazzy when you do that. But yeah, so I thought I'd like cover like some of my favorite bugs. I unfortunately didn't find them. The insects looks pretty good though. So the first one is a bug in Ruby on Rails. I was, however, the first one to publish an exploit with Luke for this bug. So it's Rails is supposed to, so it's an SQL injection in Ruby on Rails, and Rails is supposed to prevent SQL injection by design because they got this all active record mapper, which is very solid. And at the time, there were no public exploit available. And I did like an exercise and a free course on it if you want to learn on pentesterlab.com. So Rails, the thing is that it was an SQL injection, but the problem is that the injection was when the application was trying to retrieve information from the table, and it was caching that information. So each query, each injection had to be unique, and the exploitation was completely blind. So it's a really interesting bug to exploit because of the way you have to like understand that, okay, why is it working this way? Why my payload works once, but if I send the same payload, I don't get the same result because of the caching, obviously. But when you don't know that, it's really interesting. Yeah, just a little puzzle to solve, I guess. Yeah, I really love that bug. Another one is CV 2012-6081. So it was used to hack Python and Debian's wiki in 2012. The exploitation is just brilliant. And again, like free ISO and course on how to exploit it on Pentesterlab. So it's a directory traversal in the upload. So it's pretty simple, right? You have a directory traversal when you upload a file. And if you just look at the advisory, it's something like that. You're like, boring bug, seen that before. I'm not going to look at that. But then you realize like, oh, Python and Debian are a big project. They're using that wiki. It's very worth looking a bit deeper. And then you realize that the injection, where the directory traversal is in the file name extension. So what happens from there is that the payload can only contain one dot at the beginning. So once after the extension, it's game over. So what you're going to do, and as well as the file is upload and is starred. So it's going to add a limit of max 100 bytes to avoid, like when you got a tar that is under 100 bytes, it's going to be like the file. But if it's over 100 bytes, it's going to add like long link inside the tar file. So you don't want that, right? And then the payload needs to be a valid 1.1 plugin. So you need to write Python in less than 100 bytes, starting with drawing, because that's the name of the file, but when it's renamed. And then you can inject everything in your extension, but you can't have a dot in the injection. And you end up with this weird Python that I didn't even know you could use that syntax, right? Like drawing.z, if else, like that. Like I did too much Python in my life, and I didn't know about that syntax. And that's what the exploit looks like. Like you need to have the execute function with the request. And so what you do is you print the value that you execute back in the return. And that's how you exploit that bug. But it's like brilliant to be able to like find this exploit. I didn't find it, someone else did. And then a really well-known one, go to fail. So it was a bug in the iOS and iPhone stack, the TLS stack. So basically a TLS verification bypass when some specific algorithm were used. And the interesting part is first that the algorithm were the one used for forward secrecy. So basically people who cared a lot about security and were doing the right thing by using forward secrecy were the one impacted by this bug. The other thing is that actually everyone was impacted because you could write a malicious server, but if the client was accepting that bug amongst that cipher amongst a lot of other cipher, it will use that cipher over the other one, because you could write a server that would just send the only cipher I talk is this one with forward secrecy. But the really interesting part as well was that this bug was bypassing public key pinning, because what you had to do is create a malicious server with the real certificate and the real certificate, like the valid legitimate certificate chain, but you could use any private key. Since public key pinning relies on the certificates or the key depending on the implementation, that was going through TLS pinning without generating any issue. So the most secured application, relying on forward secrecy, relying on Diffie-Hellman, ECD, IHE, relying on public key pinning, were owned by this bug. And yeah, so, and really interesting to exploit. So let's get started. So my advice to you is just try to pick one bug per month and study it. Do a code diff, do a test lab, write an exploit. Really simple, like literally it's going to take you like 2 or 3 hours. I'm convinced you will learn a tremendous amount about software security. And that's the kind of thing, it's like deliberate practice, is reading an advisory or reading someone tweeting about like the latest F5 bugs or the latest Citrix bug or like all these bugs is not going to teach you much. But doing that, like deliberated practice, like struggling to get things working, struggling to understand source code, really will get you to the next level, I think. And then you can do a talk at your local CSides or any conference, like any small local conference, and you're going to get exposure. If you're looking for a job, just do that. Like that's the best way to find a job. If you can talk about bugs, show that you're really passionate, you're willing to like get your hands dirty looking at source code, it's going to be a lot easier to find a job in security. And that's it for me. You can follow me on Twitter with Sniff or Pentester Lab. And yeah, that's it. Thanks for your time. Thanks, Silvio.
Well, thanks very much, Louis. That's a great talk. It's very relatable for many of the things that you said in that talk, actually.
Actually, there were questions on Slack, but Silvio kept answering them for you.
Badly answered them badly, by the way.
He was like, I love this talk. This is my thing.
But there was one question that I took from Eleanor who talked about, and maybe answered it at the end a little bit, but she said, so if you've got developer experience and you sort of know a little bit about security, some exposure just as sort of a general practitioner of sort of IT, how should you get into the bug hunting world? You know, like, is it back to what you talked about at the end, deliberate practice and stuff like that?
I think so, yeah. And I think depending on what's your strategy, like you can either deep dive on few bugs. Like if I were a software developer, I will look at something really hard to build. Like one example is OAuth 2. Really hard to build, really hard to get right. So if I were a software developer, I kind of am, I guess. What I will do is I will look at example of bugs for that technology. Look at SAML, look at OAuth 2, look at JWT. That's kind of what I'm doing already. And then since you're a developer, you can write code, you can read code. So you should be able to like say, okay, this is how things work. Look at exploits written by other people, look at what they're doing. And then you keep testing that on bug bounty programs or like source code and see like, okay, this is how it works. But what I would do is like really spend time and narrow down what I'm going to look at and pick something that others like security professional will have trouble getting into because it's actually hard to build it. And that's where you're going to have like an edge on everyone else because you're a software developer, and that's where I would get started.
I like that. I think that's really good, actually. I know for like even for fuzzing and stuff like that, getting harnesses and stuff like that is like, I mean, you know, if you're a pen tester, you might not have dev experience, and you've got a real edge as an engineer like that goes into it. That's really insightful, actually, that you've just said.
There was another question there from Pam on Slack. You mentioned, you know, find a pattern and then look for it in other languages and other sources. She asks, are there any favorite sources for regex, coccineal, semgrep, etc. For bug patterns?
So I know semgrep has like a lot of, we got a project for like a Python named Bento, where they provide like a lot of examples. And I think we got like an open source library with like a lot of patterns to use to check for bugs. yeah. But CodeQL as well, the GitHub security team is doing an amazing job at sharing the bug they found and how they found them with CodeQL and how they scale their work using CodeQL. So like all these people are providing patterns of like interesting bug you should look at.
And GitHub Lab, like GitHub Security, also provide bug bounties, don't they, for CodeQL queries that find bugs and stuff? It's pretty cool.
Yes. Yeah. Yeah. So I like CodeQL because I think it's a lot more powerful than SemGrep. But if I were to start, I would probably look at SemGrep first because it's just writing YAML. So the barrier to entry is a lot lower.
The only thing I don't like about CodeQL is you have to build the package to actually use it. So like Coccineal and stuff like that, you can just scan, like doesn't even have to be working C code.
Oh, you mean Coccineal? Oh, sorry.
Yeah. So how do you pronounce that?
You did really well. I'm just giving you shit.
I heard someone's correct me once when they said I've worked with the author of it, and so like I've been pronouncing it Coccineal. Is that correct? How do you pronounce it?
It is.
Oh, there you go. I'm gonna hold you to that now. I'm gonna...
Awesome. Are there any other questions?
Favorite researcher to follow for well-presented bug write-ups. So I think someone asked me about recently, for write-ups, I would probably look at GitHub Security Labs. They're like doing write-ups. Bass is doing really good write-ups. Silvio is doing pretty good write-up, but I think they're not always beginner-friendly. Who else? Project Zero are doing really, really good write-ups. Some in the bug bounty hunting scene, I think Dev Param is doing really, really good write-ups of what he found. Who else? Like a lot of people. Yeah, I'm gonna forget like a lot of people, but Eltam has a really good blog with like some good write-ups of things they do. So many people, like
Yeah, great. So thank you very much. Have we got any more questions before we sort of close out?
No, I think, but if you go onto the Slack afterwards and let people ask directly, that would be great. And thank you. Yeah.
Thank you very much for your talk. It's a fantastic talk.
Thank you.
Thank you.
You just say that to use your soundboard.
It was a great talk. It was a very relatable talk as well. Sure.
And I think we did well because last month, by this time, Silvio was sitting next to me sharing my microphone.
I had some problems